Here we go with a set of notes on reptiles. This one kind of similar to the amphibians. We'll talk about the defining characteristics of reptiles, discuss some of the different types, and then look a little more in depth at some of their organ systems and how they compare to the amphibians. So the two main characteristics that we're going to talk about reptiles and characteristics that define reptiles are really adaptations for their life away from the water. You remember amphibians are tied to the water. They have to come back to the water at least to reproduce. Reptiles do not. They can be totally away from the water. And they have two main adaptations that allow them to live life away from the water. First off is their egg. They have what's called the amniotic egg. This is something that's probably more familiar to you. It would look more like a chicken egg as opposed to, remember the images of the frog eggs from the last presentation. They're like a gelatinous blob. They definitely require water. There's no way they could survive without the water. These eggs, they do not need water. They basically take the pond with them wherever they need to go. So they have that shell for protection that contains inside it the embryo and everything it needs to survive. The embryo is going to have yolk for fat, so that's why egg white omelets, people often order those to reduce the calories of their breakfast. That's where all the fat is. And then there's also the albumin, which would be the egg white, and this provides some protein for the developing embryo as well as a source of water. So again, this allows these guys to totally break away from water. They don't need that water at all. The second adaptation is that these guys have watertight skin. You recall that the amphibians definitely do not. They absorb a lot of stuff through their skin. Reptiles are not this way. Their skin is covered with scales, which are made of keratin. It's a type of protein. It's actually the same protein that's found in your fingernails, so it's kind of a nice hard armor covering. And then the scales are usually coated with lipids. So remember from Biology 1, lipids are things like fats, oils, and waxes. They all repel water. Think of oil and water, they just don't mix. So this helps protect the reptile, so it keeps its water inside and doesn't lose a lot of water through evaporation. So it allows them to move onto land totally. To talk a little bit about the reptile taxonomy, within class Reptilia, we have a couple different orders of reptiles. First one is Testudines, or Testudines. These are the turtles and tortoises, just kind of like the name sounds. And there's Crocodilia, which would be the crocodiles and alligators, the crocs and gators. In Squamata are the lizards and snakes. This comes from Latin for flat, so these guys are kind of flat, low to the ground. Sometimes the snakes are obviously low to the ground, some of the lizards are. And then there's a fourth order called Rhynchocephalia, which is a really, really small order. Actually, there's only 2 species of organisms. That's these guys right here. They are lizard-like reptiles called Tuatara, really only found in the northern island of New Zealand. So their range has been greatly diminished. It's thought that they're sort of more like an ancestral order, so kind of like bridging the gap between older groups of reptiles and the newer, more modern reptiles. As for some of the organ systems of reptiles, we'll start off looking at the circulatory system. Kind of similar to the reptiles, these guys also have a 3-chambered heart. So they have 2 atria, atria, ventricle, 3 chambers. And they also have a 2-loop circulatory system, so blood's going to go from the heart to the lungs, back to the heart to the body, back to the heart. So 2 loops, the pulmonary loop and the somatic loop, or the body loop. The difference between reptiles and amphibians, though, is that reptiles have a little bit of an addition, something called a septum, which is a wall. And so you can see that wall right here. So they're one big chamber, the ventricle, compared to the amphibians. It's got that wall. These guys don't have that wall, and that reduces the mixing of the blood with and without oxygen. So it makes it a little bit more efficient as far as that goes. So pretty much the same, but less mixing, so they're getting a little bit more oxygen. As far as the respiratory system goes, reptiles are going to be strictly using lungs because they're living on land full-time now. And some unique structures in their nervous system is something called the Jacobson's organ, which allows them to have a really, really good sense of smell, and you can see how it's closely situated by the tongue. So this is, you guys probably know why reptiles sense their environment, especially snakes, always flicking out their tongue, sort of smelling with their tongue. It sort of increases that sense there. And then these guys also have another addition to their skeletal system. So same as before, they kind of have a robust skeletal system for supporting on land, and they also have the atlas, just like the amphibians do, but now they have the second vertebrae. C2 is called the axis, like axis of rotation. So this guy right here is the axis vertebrae. And this little guy right here, this thing called the dens, you can probably see fits right along with this guy and allows that atlas to turn left and right. So now reptiles can say yes and no. They can nod their head up and down saying yes, and they can shake it back and forth to say no. A little bit about reptile reproduction. Some terms that we often use. They can lay eggs. A lot of them lay eggs, which is called oviparity. Right? An ovum is an egg. Comes from the word ovum, O-V-U-M. These guys are the ones that lay eggs, so that's called oviparity, or they're oviparous. Or they can show viviparity, which means they're born alive. I think maybe the Spanish word to live is vivir. Vivo means to live. Viviparity, they're born alive. Well, obviously, they're all born alive, but they're born more developed, more like a regular living organism. They do not have an egg. So they show viviparity, or they are viviparous. Viviparous. So those are a couple terms that you would be associating with these guys. The next thing we need to talk about when we talk about reptiles is their processes of thermoregulation, thermo being temperature and regulation control, so how they control their body temperature. Reptiles, as you probably know, are cold-blooded. Right? The term for that is ectotherm, meaning ecto meaning outside, therm meaning temperature. They absorb their body heat from the outside world. Okay, so their body temperature is based on the temperature of the outside environment. The advantage to this is you don't have to eat a lot, right? Warm-blooded critters need to eat a lot. Think of yourself. You're always eating. You have to feed your furnace, right? You have to keep your wood stove going. You have to keep feeding logs to it. You have to keep feeding cheeseburgers to it to keep that temperature up. These guys, they do not have an internal furnace. They're just relying on the outside world, so they don't have to do that. They only have to eat to provide energy to move around, right? Whatever it actually takes. So that's the advantage. They don't have to eat as much. Right? I don't have to feed Dracona once a week if I really wanted to, and she would be totally fine. The disadvantage of this being that their activity is based on the outside temperatures. Right? So Dracona's getting her heat from the lights and the lamps and the heat rock and everything else in her tank. Right? That's what's providing her heat. But if I were to come in the morning before all those lights turn on and throw some crickets in there, yeah, she might want to eat them, but it'd be pretty hard for her to get them because she wouldn't have a lot of body temperature. So if it's cold outside, they can't move very quickly, and that could be a big disadvantage. So things that are cold-blooded, fish, reptiles, and amphibians, these guys are all cold-blooded. The opposite of that being, of course, like I just said, what we are warm-blooded critters. Okay, so we're endothermic. We generate our body heat inside our bodies, so we generate our own body heat. The disadvantage of this is we need more calories. Like I just said, we're always eating to feed that furnace. Right? Keep that body temperature up, maintain that 98.6 degrees Fahrenheit. We're always needing calories to do that. Of course, the advantage to this is activity is not related to temperature. Right? You're always ready to escape. You're always ready to go run a mile. Well, relatively speaking, you can move around whenever you need to. You don't rely on the sun's energy to get you up and going. Okay? So that concludes what we have to say about reptiles. And the similarities and differences with the amphibians. The main thing is they're adapted to life away from water, so they bring those pond with them with the eggs, and they don't dry out. They've got a 3-chambered heart with a little bit of a septum, so they can have more oxygen, less blood mixing. And then, of course, they're cold-blooded, just like the amphibians, so they have to absorb their heat from the outside instead of generating their own heat. So again, be aware, probably having a quiz on this next class, so we might want to review your notes before class.